In this lesson, you will get an introduction to the concept of object-oriented programming using the Java language. Please go to the lesson website and take the time to download the Objects Introduction document in either Microsoft Word or PDF format. Pause this lesson and read the document carefully. You will need to have a grounding in the terminology used during the lesson, and a familiarity with the code we're going to write will make it easier to follow along. Then continue the lesson. In Eclipse, we will be creating a new Java project, which we will call Object Introduction. Within this project, we're going to create our first class using the new class, and our class is going to be called Simple Object. Now, up till now, we have most often checked the public static void main box, but this class will not have a main method. Instead, this class will be instantiated by another method or class that we will write later. So, take a moment to add your name and class to the top of the program and the date. Then we can begin writing the code for our class. An object in Java, and most other languages as well, will have a system for instantiation. Instantiation is the process of creating one of these objects from another program. And the method for creating an object is called a constructor. A constructor always has the public keyword followed by the name of the class. And as it's a method, it must have the parentheses followed by a curly brace. Notice that this method is different than all other methods that we've written so far in that it has no return type. That is what marks this as a constructor method, and it is called in a very special way. Now, what does a constructor do? The job of a constructor is to fill any instance variables that the object has with its initial set of information. Well, you may ask, what is an instance variable? An instance variable is the information that this object keeps track of. So for our object, we're going to start by creating a couple instance variables. The first one we're going to create is going to be a string, which we'll call name. Now, up till now, we've always made our variables static, but this is not a static variable. Furthermore, we've usually made them public. This variable needs to be private. So this is the complete declaration. You'll also notice that there's no initial assignment giving this variable a value. That is the job of the constructor. So the constructor is going to take this variable name and give it a value, which in this case will be empty or blank. And that is the complete process for creating a simple constructor, a simple object that has only one instance variable. Now, let's see how we use this object in our code. So we're going to go back to the default package and create a new class, and this time we're going to give our program a name that indicates that this program actually is the one that does some work. So, what do we want to call it? It is not uncommon to give it a name that indicates that this is the start point. So we can use the name of the class that is the basis for this project, but then we're going to add the word driver to it, indicating that this is the start point. and then we're going to check the public static void main box. Okay, once again, we'll take the time to put our name, class, and date into the program, and then we'll delete the unneeded comments. And we're ready to begin writing our simple code. So, we have this object class that we've created. What we want to do is what's called instantiation. Instantiation is the process of taking an object that you've outlined, that you've written the code for, and bringing it into existence. And when we create a variable normally, we specify the variable's type, then a variable name, and then we give it an initial value. And instantiation looks very similar. So let's go through each of those steps. The first step is to give the type of the variable that we're creating. In this case, it's going to be a simple object, because that's the name of the class that we've created, simpleObject.java. Then we're going to give our name. Now, I'm going to call this thing1. And then I'm going to use the assignment operator. And this is where things get a little bit different because it's an object that we're creating. We're going to use the keyword new, followed by the name of the method or constructor that we're using to create this object, which is simpleObject. And because it's a method, it has parentheses on the end, and then a semicolon. And we are done. We have now created this object called, or this variable called thing1, which is a simple object. Which is good, except that there's not a whole lot that we could do with this object because so far it really doesn't do anything. But all objects have some built-in methods. So just to see what you can do with this object already, we're going to put in a print line statement, and we're going to print thing1. Now, how do you print an object? Well, it turns out that all objects have a method built in, and if I do dot here, I can see a list of these methods. And you'll notice that one of these methods is toString. The toString method is a built-in method that all objects have, which will return a string. And since systemoutPrintln tries to print a string, the computer will automatically actually execute the toString method. So even though I didn't say toString, I left this off, what happens is thing1 gets cast into a string using the toString method. So first, let's try it this way and just run it and see what we get. Now, notice that in my console, I got simpleObject, which is the type of object, followed by some strange numbers. And what this amounts to is where this object is stored in memory, which is not terribly helpful. So, what's one thing that we can do to make this more useful? Well, if we go back to our simpleObject code here, we can add a method. And one of the methods that we can do, that we can add, is a method that lets us override the toString method. The toString method returns a string and has the name toString. What happens here is that we have redefined how the toString method operates. So we're going to return some string. How about if we say hello? Save our program. I'm going to go back to my driver and run it, and let's see what we get. Since I did system out on thing1, and thing1, the println method needs a string, my objects method, toString method, gets called, which returns the value hello. But obviously that's not exactly what we would want to return. What would make more sense is to return the name of the object. So let's put that in and then go back and run our program again. And of course we get a blank console because so far our object doesn't have a name. Now we could go into our constructor and give it a name. I am Michael. And then we can run it, and now we'll see that it returns I am Michael, because I have set the instance variable name to the value I am Michael, and then the toString method returned that value. However, it doesn't make sense to give every simple object the name Michael, so let's set it back to blank. What would make sense is if there were some way for us to give our object a name. And this is where we can add a new method. By the way, let's take a moment and label the things that we have created so far. The first thing is that our variable here is an instance variable. The next thing that we have here is our default constructor. And a default constructor is generally defined as the constructor that has no parameters. We'll get into more detail about what other constructors might look like shortly. And here we have overridden the toString method. So next what we're going to do is give ourselves the ability to give our object a name. So we're going to write a public method, and it's not going to return a value, it's going to let us change the name of our object. So its return type is going to be void, and we're going to use setName as the name of our method. And then of course we have to pass it some variable, so we're going to call it setName since that's what we're going to do with the variable. All we need to do now is change our instance variable to have the value given by setName. Okay, what we have just done is written what is commonly referred to as a setter method because it sets an instance variable. It is also referred to as a mutator because it changes or mutates the value of an instance variable. Okay, so how do we use this new method? Well, here we instantiated our thing1. Now we can call thing1 and look at the methods that we have. And notice that there's a new one in the list, setName. If I select that, it fills it in for me, and the first option here is to put in a value for the name. So if I wanted to call my thing1 Michael, all I have to do is pass the value Michael. And then when I do system out, what should I get? Well, I should get the value I just put into it. If I then wanted to change the name, I could do that. How about if I wanted to be able to retrieve the name from my thing? How would I do that? Well, I would go back here and add my other class of method, which is my getter method, or methods, which is often referred to as an accessor, or accessor method, which I think I might have spelled wrong, but we'll go with it anyway. So this would be a setter. Right now there's only one, but we're going to put multiple ones in, so we'll make it plural for later. Okay, now I'm going to have a method. Now, a getter method is supposed to return information from my object. In this case, we want to get the name. So what type of variable will it be returning? Well, it'll be a string. What will that string contain? It's going to be the name. What parameters does it need? Well, there are no parameters because it's only getting information. What does this method need to do? Quite simply, it returns the name. Now, I go back to my simple object driver here, and I can say string who are you equals thing1 dot, and notice I have my getName method right there. So now I can output who are you, and once again I see Michael. So let's see how we can use these methods a little bit more creatively. How about if we take who are you and we add to it a last name. How would we then change thing1 so that it has the whole name? Well, we would do thing1 and we would use our set method, our setName method, to set, but this time pass it our variable. And so now we get our first and last name. Okay, so we can now think about how would we add, let's add another instance variable to our class. What do we want to do? We're going to add a private variable that's going to be the integer, and it's going to be how old this thing is. And if we've done that, we should be able to write a setter and a getter for this class. So let's start by writing our setter method. Once again, it's going to be public void, and we're going to be setting the age. This time we're going to be passing in an integer. We'll give that integer a name called setAge, and then set the instance variable age equal to setAge. And we're probably going to want to be able to get that information, so let's also do a public int getAge method that also returns our age. So now we've very quickly written our setters and getters for the age instance variable. So now I can, once I have instantiated my object, I can set its age. Now, how can we use this? Up till now, notice that our getName method does exactly what our toString method does. But let's make our toString method a little bit more interesting. So it does something different than getName. Let's make it return I am plus the name, and I am plus age years old. Okay, so now if I go back to my simple object driver program and run it, whoops, did I do something wrong? What did I do wrong? Let's see. Oh, system out print who are you. This is not printing what we wanted. I want to print thing1. So my system out now is back to printing thing1, which should call my toString method. There we go. I am Michael Beck, and I am 21 years old. Okay, so we're ready to move on to a slightly more complex little change. Often, when you're creating a constructor, what you want to do is have other forms of your constructor to save you some time. For example, commonly when you create an object, and in this example we might want to give every new object a name and an age. So we're going to create a method here that is another version of the constructor. Only this time it's going to include a string setting the name and an integer setting the age, so that we can create an object and give it a name and age as soon as it's created. Furthermore, we should go in here to our default constructor and set our default age when we create a new object. So, what do we have to do in this version of the simple object? Well, what we need to do is say name is equal to set name and age is equal to set age. So that we've now given each of our instance variables an initial value. Now, notice that we have two methods that have the same name, but they have different method signatures. The method signature is the combination of parameters that goes with that method. This method has no parameters. It's often referred to as a no-params method. This version takes a string and an integer. So how do I use that in my code? Well, I'm going to instantiate a new simple object, which is going to be thing2. So I use the new keyword operator and the method name. Now, if I don't include any parameters, which method, simple object, this one or this one, will get called? Well, the computer will look and see that there are no parameters, so you must intend to call this one. If, though, instead, I give my new object a name, followed by an age, the computer or compiler looks at the fact that I've included a string and an integer. So it looks for a method called simpleObject that has first a string and then an age. And finding a match uses that version. So then I can simply do a system.out.println on thing2 and see what results I get. I am sheathing and I am 26 years old. So what is this process called? When you have more than one method using the same method name but different method signatures, you are overloading that method. And the compiler chooses the correct version based on the types of the parameters that you've used. It matches the method signature. So, if I wanted to label this, we could say this is an overloaded constructor. Okay, we have written a complete object that really uses all of the fundamental features of object-oriented programming. We have our constructor and we have an overloaded constructor. We have two setter methods or mutators that alter the instance variables within that object. We have two getter methods and we have an overridden inherited method, the toString method. Believe it or not, that is fundamentally every key aspect of object-oriented programming. Of course, things get a bit more complex and we can get very creative with the ways that we use these. So let's take a simple example and see how we could write this into a program. Let's say that we wanted to make it possible to allow a thing1 and thing2 to get together and have a child thing, but only if they're old enough to reproduce. So how could we write that? Well, we can write a conditional statement if thing1 dot getAge is greater than 18 and thing2 dot getAge is also greater than 18, then we'll allow something to happen. What's going to happen? Well, in this case, we're going to create a new thing. So we're going to say, how about simple object, which is our type, followed by our object name or our variable name, which will be thing3, is equal to a new simple object, and we'll instantiate this simple object, giving it a name based on the names of its parents. So what will we call it? We'll call it thing1 dot getName, but in front of that we'll put son of thing1 dot getName plus and thing2 dot getName, and then we'll give it an age. Since it's a newborn, it will have an age of 0. And then we will do a system out print line on thing3. Now let's run our program and see what we get. I am the son of Michael Beck and she thing, and I am 0 years old. Now what happens if I go back and I set my thing1 to have an age of 5? Well, then I don't get a child being born. So you can see how I've used an accessor method in a conditional statement combined with another accessor method, and I have also then used my instantiator or constructor to instantiate a new thing, and I've used my getters to get the names and make it part of the constructor for this other object. As you can see, the interactions can get quite complex. And that concludes this lesson.